on?
Yeah.
Okay. Liquid nitrogen. Liquid nitrogen is minus 196 degrees Celsius. And we talked about water being between 0 and 100. Melts, boils. Now, we take 100 and we put it down here. For liquid nitrogen, we'd have to put it down here to get to almost minus 200. So, it is 100 degrees colder than dry ice. Okay, we're talking super cold. So you don't want to mess around with it too much. All right, I know they use it for all kinds of things, and making ice cream or whatever, but you have to be careful with it. Okay, so that's what we're talking about. But where water below this is a solid, nitrogen at this temperature is still a liquid. Okay? Nitrogen does have a graph like this, but these temperatures are way negative. Question?
How cold would it have to be a solid?
I looked that up. It's like minus 210. So
it's almost there.
it's almost there. Okay? All right. So got put some liquid nitrogen in a bowl.
No, it's not over the
Come
table.
closer. Now, the first thing a student thinks of is, can I touch it? Well, closest thing to your finger is a hot dog. Okay? You guys can come up closer. You guys come closer. So, what would happen if we put your finger in the liquid nitrogen? Well, let's find out. Now, the hot dog was room temperature, meaning it's 200 degrees hotter than the nitrogen. So it has a lot of heat in it. A lot of heat in the hot dog. So right now, with the hot dog in the nitrogen, where is the heat moving?
Outside.
From what?
The hot dog.
From the hot dog into
The liquid nitrogen.
into the nitrogen. So, what you have here now is, because of the heat of the hot dog,
Finger.
you are seeing the nitrogen.
Smells terrible.
You're seeing the nitrogen boil.
It smells like a hot dog.
Now, you say, well, wait a second. Boiling. Okay, so you're seeing boiling at minus 196 degrees. Now, I thought boiling had to be hot. Does boiling have to be hot? No. It's the boiling point of nitrogen is a super cold temperature. We say cold. Cold is a word that was invented by humans based on how we feel. In chemistry, it really doesn't exist. Okay? All right? So,
That thing is frozen.
that thing is frozen. That thing is frozen.
Chuck it. I saw the picture.
Okay? That thing is frozen.
Drop it.
Oh my God!
Oh, piece of
nitrogen here?
Yeah, shatter it. Put 100. Put all of them. Get all of them in there.
All right. So the pennies are room temperature. So again, the liquid nitrogen is boiling because the pennies had heat in them.
Yeah.
Okay? Now while those cool off, I want to talk about water for a second. The other day we took ice to a boil. And we saw just how long and how much heat was required to get the water to move in temperature. So this is holding a lot of heat. Well, if we put it in the nitrogen, it should boil the nitrogen. And you'll start to hear it more as it goes here. And it'll take a little bit of time here. It doesn't just freeze. It takes a while for heat to move out of it because it took a while for heat to move into it. Okay? So you're hearing it more. That heat is really starting to get pulled out of there.
Put the mask on. Put the mask on. You ate the hot dog.
Okay, now you hear it slowing down. The water that's underneath the level of the nitrogen is getting frozen. Now what you have here is for your freezer water, it is just below zero. They take it down to like -4. And then you have a solid in your freezer that you use. This, however, you go way down this diagonal line, way down, and that's where we are. So, with room temperature, and as slow as it takes for water to move, this frozen water.
What are you doing? He broke the table. He broke the table.
It was like that. It was totally like that.
This frozen water is going to stay like this for a long time. I'll leave it right there, and we will see what happens during the rest of the period. Girls in the back, pay attention. So we will see what happens. A regular piece of -4 degree ice would probably melt in, 10 minutes or something like that. But we'll see what happens with that. Question?
Is the plastic frozen?
The plastic was already solid, so. All right. Now, I have a balloon here. Oh, let me try the alcohol first. I've never done this before. This has alcohol in it. See what happens to the alcohol. You can hear the sound went faster. And now it's slowing down. Close that door.
I wonder what it would taste like if you...
All right, let's see what happens. All right, there's some frozen alcohol in the bottom, and that went fast.
That was a lot.
Whereas water went slow. Okay? See the frozen part in there. All right. Now, need some more nitrogen. I have a balloon. The balloon has room temperature air. It is 200 degrees hotter than the nitrogen. Okay, keep that range in your mind. Now, we're talking about the transfer of heat. This balloon, this gas, is up here, and the dots, the molecules, are far apart in here. The reason the balloon is blown up is because the atoms inside, the molecules inside, are banging around on the inside of the balloon, pushing it. So, can we slow these down and get them to be closer together?
Yeah.
Yeah, by taking energy out. Well, what will take the energy out? The nitrogen. All right, so we'll put this in here.
Yo, it's deflating. The air inside is freezing, guys.
Well, that makes sense.
No, it
Because they're
doesn't.
moving closer together.
Right.
Could you swap?
It's going through the table.
Oh, now the balloon's all weird. Looks like a Megamind.
Now, we talk about how far the molecules are, how far apart they are. Well, let's just see how much really empty space, that's the key thing right there, empty space. Let's see how much empty space is actually in this balloon as we get the molecules closer together. All right, well, where did the balloon go? All right, I'll do this a couple times, one for each side of the room. But, all right, right here, you can see that there is liquid inside the balloon. It is liquid nitrogen and oxygen. And right now, the balloon is reinflating. How is the balloon reinflating?
Because of the heat.
There's gas.
Because the oxygen is expanding.
Think about energy. Why isn't it reinflating? Think about energy.
Because of heat. Room temperature.
The heat in the room is causing it, is going back into the balloon. Okay?
So that's liquid oxygen.
And nitrogen. Okay?
I feel like I should be videotaping.
All right. Okay, let me do that again.
Should have done it with helium.
Put the glove on.
Yo, what if you did it with helium and then the helium turns into water and then you drink it?
You get a deep voice instead.
All right, I have questions. Be quiet, I have questions. Energy right now